Hello, welcome to the Hinstitute. In this one, I'm going to see if I can explain number 8 of the vector problems. Now, things that are a little bit different is this one is not actually trying to find a resultant. We're not trying to add the vectors together. We're actually dealing with two different vectors. We have one team that's here, and we have another team that's over here. And we're going to try to find where is one team in relationship to the other one. So it's actually going to be a difference between vectors, and that's going to be a little bit different in the way we do it. The first thing I would do with this problem is I would draw a picture where I would put base camp on here. So I'm going to draw a base camp. And then I'm going to draw where these vectors are, where these positions are of these teams from base camp. So I'll start with the first team. It says that they are north of west. So if this direction is north, and this direction is west, they are heading somewhere off in this particular direction. It's like that, and they're 38 kilometers away from base camp, so I'll put a 38 kilometers on here. And then it says they are 19 degrees north of west. So that means start at your west line and measure north of it. So this is where the 19 degrees would be. If you wanted the other angle, we know how to find that other angle. That would actually be west of a north line, and that would be its complement. So that'd be 71 degrees. Probably don't need it, but just in case I do. So this is where team number 1 is. I'm going to actually be using that as kind of a guide. Team number 2, they start out at base camp, but they're going to head east of north. So here is my east line, and they're going to head off something like this direction. And team number 2 is somewhere up here. They are 29 kilometers away. So I'll put 29 kilometers on here. And it says they're 35 degrees east of north. So that means start at your north line. I'm going to measure from north over 35 degrees. Now, most of the time we don't tend to do angles from the middle of this. So I'm going to do the outside angle. I'm going to do its complement and realize that that 35 degrees east of north would also be 55 degrees north of east. Why do I do that? So here is my goal. I want to actually find where is team number 2 in relationship to team number 1. And when I do that, I should be able to find kind of the difference between these two vectors. And if I can find the difference between these two vectors, we should be able to get this. So I'm going to start at team number 1 and go up to team number 2. This is the vector I'm after, so I'm going to call this D. It's just the displacement or the distance between these two lovely vectors. So it's not actually a sum. If you notice, both of them are coming from base camp and then going out. But here I'm going from the tip of one vector to the tip of the other. So I'm actually finding a difference between these two. But I'm going to follow it the same way I've been doing. For example, I'm going to start out by breaking this 38 kilometers into how far west they actually travel. So I'm going to call this, I'm going to make this rather than 1, I'm going to call this team A, and I'm going to figure out how far west they go, and then I'm going to go north. I'm going to team A, how far north they go. So I'm going to do the same thing I've been doing. I should be able to use sine and cosine with this 19 degrees. AN is opposite it, so it would be the sine of 19 would be opposite over hypotenuse, and AW is adjacent, so the cosine of 19 degrees would be a AW over hypotenuse, and we can find the lengths of these sides. Let's do the same thing with team number 2. They traveled east a certain amount, and then they went north. From there, I'm going to call this B, team B, so I'm going to figure out how far east they travel and how far team B goes north. So I'm going to do the same thing. This is why I like to use the 55 as opposed to the 35, that I can make a triangle on the outside. So I can use sine and cosine to find opposite and adjacent. My ultimate goal is I'm trying to find D here, so I want to try to figure out what is D. That's going to be the distance between these. So I want the length of this big long vector. To do that, I need the sides of it. So to get from team 1 to team 2, basically you have to do two things. They're going to have to continue north a certain amount. And the only reason I know that the picture kind of looks like this is I've done this problem before. Your picture may not set up like this, but this will hopefully help. So they're going to be so far north, and then they're going to have to travel so far east to get over to team 2. what I am going to do to find this D here is let's find what this D north and the D east is. Now normally I would be adding vectors, so I would take the norths and add them together. But this time what I want to actually notice is that if I take AN plus DN, that's the same as BN. So I'm finding the difference between these. So this one's a little bit different, that to find the length of DN, it would actually be the entire length that team B or team 2 does minus how far north team number 1 is already. So this allows me to find this side of the triangle. Then I'm going to do the same thing with DE here. I basically, if I think about it, team number 1 has to backtrack whatever AW is and then continue another BE. So you go, wait a second, I didn't think we added west and east, but again, we're actually finding a difference. So what I'm doing is I'm taking west and east and subtracting them, but since west is in the opposite direction, it's like subtracting a negative, and subtracting a negative is like adding them. That should allow me to find D, because D squared would equal your DN squared plus DE squared, and you've got Pythagorean theorem. The harder one is to find the direction measured from due east. The way I have my picture drawn, I would probably find this angle, I'll call it phi, which is how many degrees from the north line you are, because that's the easiest way to find that. But they actually want you to find theta. Theta, if I draw a little dotted line here, if this is my east line, this is what theta would be. Well, here's the nice thing is theta and phi are complements to each other. So you can either find phi, subtract it from 90, and you've got theta, or, like we've mentioned before on previous ones, that this east line and this east line are parallel. This angle up here would also be theta, and so you could find your theta that way. The advantage of this theta down here is it's going to be so many degrees north of your east line to actually get there. Basically what we're doing, if you think of it this way, is we're going to take another triangle where we bring it over here and then bring it up, and that we'd be using this gray triangle here. And the only reason I don't typically draw that is because I'm kind of cutting through other things, and I think it makes it difficult to understand. Hope that helps a little bit with number 8, and you finish out these vectors with some confidence. Take care.